This is the tic-tac-toe robot presentation for Group 7 in the Engineering 141 Honors section. The group is Elliot Bailey, Olga Uvarov, and Will Fishburne. The problem that our group was presented with was how do you play a perfect game of tic-tac-toe? And our goals were to create a function that plays tic-tac-toe perfectly, create a function that will read the board and return to the main program what the board looks like, and then finally create a function that will play the ball. For previous methods, we had several different ones. Our original idea was to go through every single scenario that the computer could possibly do. This was the most obvious idea for our group, and we feel this is probably the most obvious idea for most groups. While this would have worked, it quickly became very time-consuming and labor-intensive. We were able to get through the computer going first, but once the computer had to go second, it quickly became very difficult to block every single different move that the user could possibly do. So Olga came up with this new idea from a website that she found where it looks at the board and then rotates it to look at the board again, because essentially the tic-tac-toe board is symmetrical. You just rotate it 90 degrees for the different patterns. So it looks at the 16 different patterns that it has, and if it doesn't find if it doesn't find one, it goes to the next, and it goes to the next, and then it will eventually find one of the patterns. This would have worked, but once we had the program to the point that we could test the function wasn't working, and we didn't have the time to go through and troubleshoot this very complicated function to determine the move. So we came up with our final idea, which was to prioritize the moves. This idea works the best for us because it simply puts, if this move is less important than another move, then we go with the most important move, and it goes through these until it gets to the most important move that it can possibly do on this turn. Our function takes in two different variables, the first of which is board. Board is the layout of the board that has been determined by the board read function, which we will talk about later. This will be used to determine what the board looks like and what the best possible move available is. It also takes in player 1. It checks to see if player 1 is computer, and if player 1 is computer, then computer's markers are X's and player markers are O's. Else, if the player 1 is person, then the computer markers are O's and the player markers are X's. It has three output variables. The first is comp move. This is the computer move. It will be determined through the prioritization method that we have developed. And the next output variable is game, and it will output game over, or it will output the string over once it has determined that there's no move available. And the final output variable is result, which is either tie if the board is completely full and nobody has won up to this point, or win if the computer has won by placing 3 markers in a row. The first move the computer makes depends on if it is playing first or if it is playing second. If the computer is playing first, we'll have it play in the top left corner. It would work just as well to have it play in any of the corners, but for simplicity in the code, we had it play in the top left. Originally, we had, if the computer played first, it play in the middle, but we later discovered that that is actually not the best move. The best move is to play in a corner so you can set up a fork later on. If the computer plays second, then it will play in the middle because it needs to do this to start on the defense initially, which it will later use to block a fork by playing in the middle. Our lowest priority is random filler. Random filler basically just goes from square to square, across, then down to the next row, then across, then down to the final row and across, and looks for an empty square. If it finds an empty square, this is the computer's move. We have this as the lowest priority because it is basically just checking to see if a square is empty, and it only uses this if there's no other technique that it later finds that is better and more tactful to use. If it doesn't find an empty space, which would be if the board was full, it will output comp move with the string none. and at this point it will say game equals the string over, and the result will be tie. Game over is used to determine how many possible, we'll use it as a while loop, and if game is over, then it will stop the while loop, and result tie is used in the program to display the final output of the game. Our fourth priority is making a fork. A fork is a board setup that allows the player to win in two different ways on their next turn. This is the desirable thing to set up, obviously, because it ensures a win. The most common type of forks, there's a few, but the most common one is when the player gets two catty corner X's or O's, depending on who they're playing as. But when they get two opposite corners and then they put a piece in either of the corners in between, this will allow two different ways to win. And so the opponent must play a piece in between to block one of these, but this leaves another one open. Another common type of fork is the same setup with an X just moved up slightly one space, and this will still provide the person that does this move with two possible wins afterwards. Another type of fork is when the or the player makes a V, and when you make a V, you have a win diagonally and across, and we prevent this by playing our O in the middle. The computer manages to block the forks I previously spoke about in various ways. If the opponent has managed to get two X's diagonally from each other in opposite corners, it will prevent the fork of three X's in various corners by placing an O next to the centerpiece O on an edge that is not a corner, like the example in the top right. If the opponent tries to set up the fork where it has an X in the top left corner and X on the middle far right, it will prevent this by putting an O in the top right corner. Both of these two block techniques that I've just spoke about make the opponent have to block the possible win that the computer has just made, or else the computer will win on its next turn. The computer prevents the V fork by placing an O in the middle square as its first move. And this initial O is crucial, as you can see, to the other two forks being blocked as well. The computer's second priority is to block a win. The computer looks for a possible win that its opponent has by checking each row, column, and diagonal for two opponent pieces, with the other space in the row being a blank. In the top right example, it would be the bottom left corner, or in the bottom right example, it would be the middle row in the far left. And once it sees these, it will place its marker there. We hard-coded all the possibilities of the different situations that will arise, and this is how the computer prevents the other person from winning on their next turn. The first priority of the computer is to obviously look for a win. This is the highest priority because it ensures that the game will end in the next move with the computer's victory. It looks for a win by checking every column, row, and diagonal for two of its own marks, and the other mark in the row, the other square in the row being blank. In this example is obviously on the far left. The way our board read function works is that the NXT motor that controls the arm with the color sensor on it first moves slightly forward over the middle square, pauses for a second there, and then moves back over the bottom middle square. This pause for a second allows the color sensor to have time to read the color of the piece, and then once it's over the bottom square, it will also pause for a second and read this square's colors. And at each point that it pauses and reads the color, it will store that location and that color in the board layout. Then the motor that controls the board will rotate 45 degrees clockwise, and the motor will pause for a second, and then this will allow the color sensor to have time to read the color and store it in board layout. This will happen a total of 7 times, so it will have rotated all the way around the board, storing the location at each of these points. Then the board read function will determine what these colors mean. The function takes in what color the player uses and what color the computer uses. It will use these colors to replace, if it were to say yellow, it will, and the player was yellow, it would replace it with an X. And if the computer was red and the player in the location said red, then it would replace this with an O. And then after this, it will return to the main program the board layout to be used in the function that determines the move, and then the location, the function that places the ball. Our move function takes in the variable comp move, which is the computer's move, and it spits out move com, which is move complete. And this is a variable that's just juggled between all the functions so that they don't run until the previous one's complete. So the way that the ball marker is placed, it gets the computer's move, and then it runs through if statements to determine where the ball is actually supposed to go. Then based off this, it rotates the board to the correct position, and then it breaks at that point so it stops in exactly the right spot. Then after this, the NXT arm with the ball hopper on it will move forward farther than it did to read the board, because it has to go over it in order for the balls to land on the board. And then at this point, the motor A will rotate 360 degrees, causing a pin to come all the way back and then go all the way forward, popping out a ball, and then priming the ball hopper ready for the next one to be released. These are our 3 videos that we have created and uploaded to YouTube. The first shows a player playing first against a computer. The second video is the computer playing first against a human player. And finally, the last video is a computer playing against a computer. In conclusion, our program works by starting the program and getting initial information from the user, such as their name and what game type they'll be playing, the user's color, the computer's color, and then it will start a loop till tie or win. And during this loop, the user will play a move, then the board will read the function. The board will then read the board, then it will initialize the board, and it will use the tic-tac-toe function that we have been talking about during this PowerPoint about how to determine the best move. First, it will determine where to play its first move. Then it will determine if it needs to do random filler. Next, it will look to make a fork. Then it will look to block a fork. Next, it will look to block a win in the next move. And then finally, it will look to win in this turn. After it goes through this function, it will return the computer's next move. Then the main program will call the place marker function that will then play the ball in the correct location on the board, and then finally it will initialize the function, or it will run initialize function. After this, it will display the result once it has exited the loop.